Today what we're going to do is work on finding equivalent ratios. We're going to try to figure out how, when given a small piece of information, we can use that information to fill in our tape diagrams and be able to just actually solve our problems. A couple major key terms for today: part-to-part ratios. This is a ratio that compares two pieces of information. So for example, if we were to talk about our classroom, one way to think about part-to-part would be boys to girls. Okay? That would give me a part of a class and a part of a class, right? Or I could say girls to boys. Also part to part. Make sense? Or I could say teachers to students. Another part to part. So there's a lot of different ways you can break that information down as a part to part ratio. I can also look at it as a part to whole. This is a ratio that compares a piece of the total to the total number of possible. So for the example we were just using, I could say the number of boys to the total students, or the number of girls to the total students, or the number of teachers to the total in the classroom. Make sense? Those are part to whole comparisons. In your information today, you may not always be told which one is which. Some of these you're going to have to figure out what that relationship is. But understanding this basic concept will help you understand how to put that information together in order to get the answers that you need to get. Okay. On the next page, it's basically a step-by-step. This is what the process we're going to go through today for you to be able to solve these problems. When we're determining a ratio comparison, the very first thing we need to do is draw the tape diagram. Base it on the information they've given you. You're going to need to make sure you pay attention to the language. Some key phrases, stuff like more than, total, less than, together, stuff like that. Those are the key words that are going to tell you which parts of my tape diagram I'm actually looking at. So if I look at more than, I'm actually only looking at the piece where one tape diagram is bigger than the other. The part where it's the same doesn't matter. If I'm looking at total, I'm going to have to add up all of the boxes in my entire tape diagram. Okay? If I'm looking at less than, I'm looking at how much fewer does one have than the other. Make sense? You'll get some practice on this to help you to pull that in. Okay? They must give you a third piece of information or you can't solve it. You're going to use that information to determine your ratio constant. Hint, this language that they're talking about on this top part is going to give you the clue as to which part of your tape diagram you're looking at in order to determine your ratio constant. Quite honestly, guys, today's lesson is about figuring out the ratio constant. But using that tape diagram successfully will help you do that. Lesson 6 especially, they're going to give you before and after information. You're going to need to draw a tape diagram, a separate tape diagram for each set of information. And then figure out where that third piece that they have to give you fits into the whole picture. Once you've got your ratio constant, it goes in every box in your tape diagram. Now, because of the way it's set up, even with the before and afters, that's still the case. Your ratio constant is going to go in every box in both tape diagrams. Once you've solved, make sure you answer in full sentences, guys. We're dealing with word problems. You always answer a word problem in a full sentence. Any questions on this? Okay? So go ahead and turn in your modules to page 16. Actually, it's hidden right now. Just like this. It'll be down here.
Okay, for this first example, I know this looks a little intimidating because it's a big word problem, but a lot of the information in there is stuff that you need to worry about. So let's go over it. County Superintendent of Highways is interested in the number of different types of vehicles that regularly travel within the county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks at the local Department of Motor Vehicles, the DMV. DMV reported that for every 5 passenger cars registered, there were 7 pickup trucks registered. How many of each type of vehicle were registered in the county in the month of August? Okay, so they gave us a lot of information here. first thing we want to look at, we're talking about the whole month of August, okay? And then they're saying a total of 192 registrations purchased for passenger cars and pickup trucks. The DMV reported that for every, that's your ratio, 5 passenger cars, there were 7 pickup trucks registered. And then the question is, how many of each type of vehicle were registered in the county in the month of August? Okay, so we're going to have to, in the end, we're going to have to figure out the total of passenger cars where they purchased the registration and the total of trucks that purchased registration. So having looked at all that, let's start with part A. Using the information in the problem, write 4 different ratios and describe the meaning of each. Okay, what first ratio can you get out of there? Anybody tell me? With the numbers they gave you. Cars to trucks. Yes. Okay, so the first one we can write is 5 to 7, and that's cars to trucks. So give me another one. Yes, Nathan. How about this? All I did was reverse it, right? But that's a different ratio. But we're still using the same numbers, correct? All right. Now these are what you call part to part, because you're taking a part of the whole tape diagram and comparing it. So we compared cars to trucks, and then we compared trucks to cars. So with those numbers right there, 5 and 7 and 7 and 5, if I was to draw a tape diagram, what would my total tape diagram be? If you drew a tape diagram, what would these total out to be? You had 5 blocks on the top, 7 on the bottom, and you added them all together, how much would it be? Jacob? No. You're getting a little ahead of us. Nathan? 12. So that would be the whole tape diagram, right? So what would be a whole to part, or a part to whole ratio? Yes, Danny. 12. There you go. 5 to 12. So that's cars to vehicles. Cars to vehicles. What else can we get? Cable. You get 12.5. What's another one? Logan. 7 to 12. That's another one right there. And that's trucks to vehicles. So those are the 4 different ones that you could get out of the numbers that they gave you here. Does everybody understand? These ones right here, the 2 top ones are part to part, and the bottom ones are part to whole. Because we're comparing a part of it to the whole tape diagram. Good? Okay, B, part B. diagram that represents the quantity in the part-to-part ratio that you wrote? Well, it's already up there for you. Mr. Moore was nice, and he gave you the answer. That's what your tape diagram should look. The big part of this is that you guys make sure that you label the top row and the bottom row so you know what they represent. Here it's C and T. The top part represents cars, the bottom represents trucks. All right, part C. Looking at the tape diagram, how many equal-sized parts does the tape diagram consist of? If you're looking at a tape diagram, how many blocks does it consist of? Bennett? 12. 12. Equal parts. Thing isn't writing. That's okay. All right, so it consists of 12 equal parts.
Down there.
And the tape diagram on part D, what total quantity does the tape diagram represent? So, Bennett already saw the answer.
Yeah, so did I.
So it represents, this tape diagram, the whole tape diagram represents the total number of registrations purchased in the month of August, which is,
Yeah, touch it. Move it. Side down.
there you go. It represents 192 vehicles. Because once we find the ratio constant and we put it in there, we're going to find exactly how many cars and how many trucks purchase registrations, and all that will add up to 192. So that's what it represents. Does everybody see that? Okay, move on to the next part. Okay, part E. What does each part of the tape diagram represent in the rate?
Next page, guys.
Part E that we're working on right now. What does each individual part of the tape diagram represent? And here's the clue. It's what will go in there is a ratio constant. So what does each box represent? You can if you want to, or use the one that you just drew. Anybody know what it represents? What each box does? Yes, Bennett.
Does it represent a number of cars or trucks?
It does. You hit it right on the head. Move that up here. Each box represents the amount of cars and trucks needed to equal 192 registrations. Because once we put the ratio constant in there, all of them are gonna add up to so many trucks and so many cars, and they're both and once you add them both up, it's going to equal 192 registrations. So can anybody tell me how we get the ratio constant with the numbers that we have? We're looking for the total number of trucks and the total number of cars that will give us 192. Anybody know how we would figure that out? Move that up here for now. What we would do, we would take the 192 total number of registrations purchased and divide it by the total number of cars and trucks represented in the tape diagram. So there was 12 boxes in the tape diagram, right? 5 cars, 7 trucks. So we take that total, we divide it into 192, and that gives us 16 as a ratio constant. You guys see that? So we would take, and we put 16 in each box. So somebody add those up and give me the numbers. Raise your hand when you have the answer. You guys don't have to write all this out. You can just put 192 divided by 12 equals 16. Speed things up. Yes, Bennett. Say that again? Right. But how many, add these up, tell me how many cars, and then add these up and tell me how many trucks. That's the answer that I want. I know it ends up 192. But they're asking you how many cars and how many trucks. Yes, Brooklyn.
There is 48 cars and 64 trucks.
Oh, a little off.
Oh, I know what I did wrong.
Able.
112 trucks and 80 cars.
Just like that, right? So you should have came out with 80 cars and 112 trucks. That equals 192, right? So your answer should look like that. There are 80 cars and 120 and 112 trucks registered in the month of August. Okay, so always remember when they're asking you for totals, you're going to take the entire tape diagram and divide it into that total that they gave you. Okay? When they want to know a total number and then break it down by cars and trucks or apples, oranges, whatever they ask you. All right, next problem. The superintendent of highways is further interested in the number of commercial vehicles that frequently use the county's highways. He obtains the information from the Department of Motor Vehicles for the month of September and finds out that for every 14 non-commercial vehicles, there were 5 commercial vehicles. So remember, for every is your ratio. If there was 108 more, notice that we highlighted more, non-commercial vehicles and commercial vehicles, how many of each type of vehicles frequently use the county's highways during the month of September? So first thing you want to do is draw out your tape diagram, which it's already been done for you. Now this one's going to be kind of big because it's 14 to 5, but that's the simplest form. So you're going to have 14 boxes on top, and you're going to have 5 on the bottom. All right, now look here. They're asking us if there was 108 more non-commercial vehicles than commercial vehicles, right? If you're looking at the tape diagram, and you look at non-commercial vehicles N and commercial vehicles C, how many more non-commercial vehicles are there, just looking at the tape diagram? Just looking at the tape diagram, how many more non-commercial vehicles are there than commercial vehicles? Yes, Kate? 9, correct. Okay, so we're focusing on these blocks right here. Those are the 9 more blocks, right? Because there's 9 more non-commercial vehicles than commercial vehicles. Does everybody see that? Okay, so now that we know how many more we have, what's our other piece of information that they've given us? They've already given us the ratio. We got the 9. What's left? Jacob. Yep, the 108. So what are we going to do that with the 9 and the 108 to get a ratio constant? Seamus. That's correct. We're going to divide 108 by 9. So we're going to take John. What do you got? 9 what? 12. So we're going to put 12 in all of these boxes. Who has the answer for that? guys already saw it up there, but what'd you get? Let's see, Brooklyn, you got it this time? Okay, we got that 68? 168. Okay, so that's correct. So you have 168 non-commercial vehicles, and you will have 60 commercial vehicles. And if we move this whole thing up, which don't want to do that. Don't want to do that either. This is what we would end up getting, okay? That's how you would solve for it. You first find the ratio constant by taking the 9 more boxes, dividing them into 108. Place the ratio constant in all of the boxes, and once you've added up the top row and got an answer, and then added up the bottom row and got an answer, it should be 168 non-commercial vehicles and 60 commercial vehicles that use the highway. Not that hard, is it? Once you extract all the information that you need. Any questions on this? It's actually pretty simple once you get the numbers down. All right, now this one right here, the ratio of the number of people who own a smartphone to the number of people who own a flip phone is 4 to 3. If 500 more own a smartphone and a flip phone, how many people own each type of phone? So again, the first thing you're going to do is the number of people that own a smartphone, and then here's your ratio to the number of people that own a flip phone. And they give you the ratio right there, 4 to 3. Now 500 more people own a smartphone than a flip phone. The question they're asking you is how many people own each type of phone. Go ahead and draw that tape diagram. Now remember, in the previous problem, we focused on the 9 more boxes. Which box are we going to focus on this one? Because they're asking you for 500 more. So work it out. Said 500 more people own a smartphone. All right, everybody. Kate is going to explain this one to us. Okay, so what did we do after we drew our tape diagram?
Well, we're going to be focusing on the one extra.
We're going to focus on this box, right?
Yeah. And so, like last time, we just divide like the 500 more by that off is only 1. So that keeps 500. Then the 500 is the ratio constant.
Okay.
So then if you multiply 500 times 4, that's 2,000, and 500 times 30 is 1,500.
And put 500 here. That's 500, not 600. So how would we answer this? In a complete sentence, how would we answer how many people own each type of phone?
There are 2,000 people that own smartphones and 1,500 people that own flip phones.
Yep, that's correct. So the answer would be there are 2,000 people that own smartphones and 1,500 people own flip phones. That would be your answer, your complete sentence answer for the question. Have any questions? Good job, Kate.
Okay, go ahead and flip over to page 22 in your modules. Page 22, up here on the right. I did it so I can remember what page you're going to, so I forget. It should be number 6, I believe, unless it's 6. Okay, once again, we're going to start with marking our text. This is going to help us out. So during the first semester, the ratio of the number of students in art class to the number of students in gym class was 2 to 7. However, the art classes were really small and the gym classes were large. So the principal changed student schedules for second semester. In the second semester, the ratio of the number of students in art to the number of students in gym was 5 to 4. 75 students were in art class second semester. How many were in art and gym first semester? So that whole thing is our question. So bottom line is that's what we need to get to. So Noah, do you remember in our notes when I said sometimes we're going to give you the before and afters? You remember that part? This is what we're talking about. So here's our before was first semester. Our after was second semester. Okay, go ahead. Okay? So we now need to go through, we've already marked our text, so we have the information available to us. You can see, first semester was what? 2 to 7. So I'm going to do my first semester set of data, do my tape diagram. I have 2 boxes for art class, 7 boxes for gym class. Is everybody okay with that? Now we look at second semester, they changed it, right? Now it is 5 to 4. So we've got the tape diagrams already drawn out here for you. We'll give you guys a couple minutes to go ahead and write these into your modules. Okay, so let's start to work through this together. Again, they always have to give you some additional information. Just the ratios isn't enough. So we had enough to draw our ratios, our tape diagrams, but what was that key third piece of information they gave us? Jacob? 75 art class second semester. So I can now put that right here, right? So does that tell me my ratio constant? What do I need to do? Nathan?
Divide 75 by 5.
Okay, so if I take 75 divided by 5, I get 15. What do I do to that 15? John? What, when you say each box, what are you talking about?
6.
So, only in the second semester boxes? Why all of them? That's a little bit of a trick question because we're making an assumption. They didn't tell us. We're assuming that we didn't lose any students, gain or lose any. It's the same number of students. From the way the problem is stated, it sounds like that's the case. You have to do that. Okay? So making that assumption, we have 9 boxes here, we have 9 boxes here, meaning our ratio constant will stay the same. So there are a couple things you needed to double check on that, but John is right. Because it's our ratio constant, it is constant. Every box fits that number. Okay? So constant is everybody gets the same. That's the beauty of the ratio constant, guys. So now, what was my question? What is it that we have to answer? Jacob?
How many kids were in our class
First semester. So now, do I have the data to figure that out? How many were in art class first semester?
What was that?
30. Because there's 2 boxes of 15, right? And then 75. Make sense? John? Do I have to have that? Don't have to. It's good. I'm glad that you're able to do that. That's why I put it up there. But does our question require it? No, because our question specifically asks how many are in art and gym in the first semester. So we can now say there were 30 students in art and 105 students in gym the first semester. Should we write that in a full sentence? Whoa.
That's not right.
30, 60, 90, 105. You gave me 75. Supposed to be 105. I have to admit, I just wrote down the numbers without double checking. 105. Yeah, 30, 60, 90, 105. So whoever gave me the 75, shame on you. Made me look bad on YouTube. Cheat. Questions? Do you understand where all these numbers came from? Yes? Okay. Good news is, you guys get a chance to practice that the other classes didn't actually get. Every other class we've been done by there. But we have time, I believe. Yeah, we got 15 minutes. So we're going to give you guys 5 minutes. See if you guys can solve this one by yourselves. 5 minutes. It's not a whole lot of time, but I gave you the rough outline. Actually, Mr. Vasquez gave you the rough outline to be able to do. So I got to go. So I know not many of you, if anyone, finished this. But basically what we ended up with is, let me pull this up. We look at the information, said 1 to 6, and then it changed it 4 to 3. 936 was before in checking. So the first thing I could have done was say that is 936. I divided by the 6 boxes. What do I get? 156. So that goes into every single box. Now the nice thing is they did tell us it's the same amount of money, and they told us that the total number of boxes were the same. So that means that every box gets the same number, just like that. And now I can do what? Uh-oh. Apparently we didn't total it other than that. Okay, but she now has, now we can total these numbers. So we have 624 in savings, 468 in checking. Make sense? Okay, let's look really quickly at our homework. go back to page 19 real quick. Here's your first page of homework. Couple things I want to point out to you. Okay, it says last summer the ratio of boys to girls was 8 to 7. There were a total of 195. How many boy campers were there? Okay, so asking you about how many boy campers. So am I going to divide the 195 by 8 or by 7? John? So if I divide the total of 195 by 8, that's going to give me the number of boys. Abel? Why 15? 15 is not even up here. Thank you. They gave me boys and girls, right? But what was the total? 15. I have to add that up. So they didn't give me that 15. I have to read the information to figure out what to divide by, guys. That's what's going to make these problems tricky. If you don't read them carefully, you're not going to get the correct ratio constant. Everybody warned? Okay? So let's go ahead and go to page 23. On page 23, these are both going to be before and after. So going to 2 problems, but on both of them, you've got before and after. So you have 4 tape diagrams for each. Okay, this one, the really big deal, guys, you've got to do your before and after. So, for example, this one talks about there were 9 maples to every 5 oak trees, okay? So, marking your text, again, is going to be really critical. Later, there's a bug problem and he died. They did a planting, the same number of trees, but now the ratio is 3 to 11. So, I'm going to have a before of 9 to 5 and after of 3 to 11. Remember, you're always looking for that third critical piece. In this case, it's 132 oak trees after planting. That means I'm taking the 132 and dividing it by 11, not the 3 and not the 5, okay? Everybody clear on those? So, 2 problems. Shouldn't be too bad. Quite honestly, make sure you're doing your tape diagrams. Got any questions, you can always look back at this video. You can look at last class's video as well. Okay, thanks guys. You go ahead and start packing up. Bell's about to ring. Nope.